Hi, and welcome back to the channel. So, what are we doing today? Well, a couple of months ago, I put out a video. In fact, it was actually, from what I recall, on New Year's Eve of 2024, where I explained that I'd had a series of unfortunate incidents that meant that I couldn't actually play this game here, which is Wasteland. So Wasteland is kind of a precursor to Fallout, the video game and now TV series. And it's really interesting in the history of video gaming because, well, we all know how massive Fallout is today. And I'm a big fan of the game myself. I really like Fallout and what they've done with that series. It's got a very interesting backstory of how it came about. I'm not going to go into that in this video, but basically, this was produced by the same team that produced the first Fallout. They wanted to do a sequel to this game. They really liked what they'd done. The IP was owned by Electronic Arts. Electronic Arts wouldn't let them do it. So they were in a funny situation where they had the creative juices flowing to do a sequel to Wasteland, but they weren't allowed to do it. So what they did was they went off and they created a new IP, similar idea, obviously, you know, nuclear war, nuclear wasteland, etc., etc. Changed the name to Fallout, changed, you know, a lot of things, obviously. And yeah, here we are today with Fallout being a massive series. But this, if you can think about it this way, is the original Fallout. So I bought this a few months ago, before Christmas, or I think it was coming up to Christmas. This is quite an expensive item these days, bit of a collector's item. So I had to wait quite a long time for one to come on the market. Well, that wasn't a crazy price. And eventually I got this, and I'm very happy to have got it. I believe it was available on the Apple II and also on the PC. I would imagine maybe the best experience for this would be to play it on the PC, so I'll definitely do that. But I do have the Commodore 64 and 128 version here, so obviously I'm going to try that out on the disk drive here. So in that video on New Year's Eve, I recollected how basically I'd got my Commodore 128 out. That seemed to be the best machine to play this on, you know, more memory and all that. I put the disk in and then basically the Commodore 128 died. But I thought, haha, that's not a big problem because I have a Commodore 64. I get my Commodore 64 out, plug it in. The same thing happens. It turns out that there's a problem with the power switch on the Commodore 64. I didn't know that at the time. I actually thought it wasn't working. But yeah, that turned out to be the problem. And then when I actually did work out that it was the power button, I then discovered that this drive didn't work. I bought it a couple of years ago, never got to use it, went to use it, didn't work as well. So it was like this cascade of things that, you know, just didn't work. So in a recent video, I actually fixed this drive, which gave me a little spark of pride. I am not an electronics whiz. You know, it's not something that I focus on, like, say, Adrian's Digital Basement. I'm more generally interested in the machines like software and things like that as well. But I put in the effort, and I was rewarded in the end to find out that it was this chip here, which is actually a duplicate of this chip here, and this one had a failure, and I could see that because this one showed how it should work, and this one was operating in an odd way. So we put a socket in, and we put in a new chip, and that fixed it. Great. So let me put this down because this is crazy heavy. It's got a massively heavy transformer in it. There we are. So we've got the drive working. We've got the game. What are we going to do in this video? Well, we are going to replace the kernel ROM in this drive. And the reason for that is the 1541 is notorious for being a slow floppy drive. It was very expensive. It was very heavy. It's got like a complete processor in it and everything else. And yet it is still a slow drive. It's quite a complicated story about why it is. In fact, I'll link, no, I can't link above, but I can link in the description below to a video that I watched a while ago, which explains it really well, why it's a slow drive, but it's a slow drive. There is a way to fix it. You can replace the kernel ROM with one of the disk drive accelerators that were written back in the day by a couple of different companies. There's JiffyDOS, JiffyDOS, DolphinDOS. There's lots of different DOSes. The one I am using, and it's because I already have it in one of my other drives, is JiffyDOS. So what we're going to do today is we're going to burn an EPROM with JiffyDOS on it. We are going to make an adapter to get that EPROM to plug into this drive. And then we are going to benchmark the difference between using the stock kernel ROM that came with this drive compared to using JiffyDOS. And at the end of this video, hopefully we can put the case back on this drive and it can be ready to use to actually play this game. And hopefully I'll do a video on playing this game. Not really sure how that's going to work, but that's something, that's a bridge I'll cross when I get to it. So why do we need an adapter? Okay, so I'll actually show you this up close, but I'll hold it up just so I can talk. What I've got here is two sockets, and the top socket is larger than the bottom socket. And the reason for that is the top socket is the size of the EPROMs that you can get these days, which are available, which are the right size to actually replace the kernel ROM inside this drive. Unfortunately, those EPROMs are 2 pins too long to actually fit into the socket which we have in the drive. So basically what you have to do is you have to piggyback a larger socket onto a smaller socket, and then you also have to wire some of these pins together in a certain way to get that EPROM to work in that socket. Because obviously some of the electrical signals coming from the pins below do not go into the pins above. You've got a 2-pin overhang, so there's basically 4 pins not connected. So obviously you have to have some kind of wires to go to these to supply 5 volts, ground them, whatever. I've seen that done. And to be fair, this is where this solution came from. It's not janky. It's a little bit bodgy, obviously, in the way it's done, but it works. It's the proof of the pudding, as it were. But I didn't really want to do that because it's very fiddly. You end up with something that doesn't look so good, and it's just difficult to replicate. So I had a look on the PCBWay shared projects page, and it turns out that there already is a couple of shared projects on there which make this a lot easier. So I've ordered some of these boards. In fact, I ended up ordering a lot of them because it was just cheaper. You can't order one PCB like this, of this size, from PCBWay. It doesn't make sense. It makes much more sense to order quite a few because you've got to pay for packaging as well and postage, over from China. So it makes much more sense to get a lot of these and then, sell them on. So hopefully I'll be able to put these on eBay. I'll hopefully put a link in the video once I've got that ready. And if you want, you can buy these off me because I've got a lot of them. And obviously I don't really need that many. You can think of it a little bit like a group buy, when a bunch of retro guys get together and they basically buy a bunch of boards together. Because like I said, it doesn't make economic sense to just buy one or two of them. So there are 2 of these boards. This one here is it says a 2364 to a 2764. So I'm assuming the 2364 is the type of EPROM that you can't get anymore. And then the 2764 is actually still available these days. I think the 2764 works out to be an 8 kilobyte ROM. And that would contain the kernel ROM for JiffyDOS. So this is the one that we're going to start off with in this video. It's quite a simple board. We just need to put some pins on the underside and a socket on top. And off we go. We're ready to go. So that's not going to be massively complicated, right? The other one that I've got, not actually tested this one out yet, but it should work. And this one is a 2364, this time going to a 27128. So this is a 16 kilobyte EPROM that can go in here. And this particular board has a space in it for a jumper and also for a resistor. I remember reading up about this, and I forget what the resistor is needed for, but it is needed. So there's a little space for it there. What the jumper does on this board is it allows you to switch between the lower half of that 16K EPROM and the higher half of it, the upper half, let's put it that way. And why would you want to do that? Well, you can assemble basically a 16 kilobyte ROM image from 2 smaller 8 kilobyte ROM images. So you can take the ROM image from this here, the standard ROM that came with this machine, and then in the other half of the image, you can put the JiffyDOS image. And then by using that jumper, you can go between using the standard kernel ROM or using the JiffyDOS. So you basically can enable it or disable it. Of course, what you can also do, if you wanted to, is to connect a switch to that, and then mount the switch on the back of the machine, on the side, wherever you want to put it, and have it so you can switch between the JiffyDOS kernel and the standard kernel at will. Obviously, it doesn't have to be JiffyDOS, it could be whatever it is that you want to put in there. But like I said, we're going to be using JiffyDOS as an example in this video. There's one last thing I'd like to say about JiffyDOS is that it is a commercial product. And if you are going to do this, you should buy the license for it. I'll put a link to the website where you can actually buy the license. I'll be doing that once I've got it ready for this drive. And also during this video, I'll be showing you how to actually burn the EPROM, etc., etc. So hopefully, if you have a similar problem to me, you'll be able to replace your kernel ROM with a JiffyDOS ROM or whatever it is that you want to do. The other thing to bear in mind is that these adapters obviously are generic. This adapter would work just as well inside the Commodore 64 to replace its own kernel ROM, or any of the other ROMs in there actually. The only reason why I'm not going to do that is because I have an easy flash cartridge, and I'm going to keep it so I can actually just load up JiffyDOS from that rather than changing it on the logic board. There's no real benefit to me doing it. But if you didn't want to do it that way, if you wanted to replace your kernel ROM permanently with a hardware solution, you can use one of these. Obviously, I think there are 3 ROMs inside the C64. So if any of them fail, again, you've got the option of using one of these adapter boards to fix that issue. Now, let's move over to the soldering area, and we're going to put one of these together, and let's test it out. Okay, so actually, to do this, we need a JiffyDOS ROM. I've actually made one already, but you're going to need to know how to do this as well. So let's go over to the Windows PC over there, where we're actually going to learn how to burn an EPROM. So I'm going to give a quick explanation about what an EPROM is, and this is for people who are completely green to electronics. That would have been me a couple of years ago. I did hear about these back in the day, so yeah, but I wasn't very familiar with them until I actually had to use one. So EPROM stands for Erasable Programmable ROM, and the erasable part of it is via that little window that you can see in the top there. You can actually see the chiplet inside in there, and what happens is you flood that area with very strong UV light, and that will actually erase the data on the chip. Generally, once you've burnt a chip, it's good practice to put a label over that little window. It's been said that it requires a huge amount of UV light to actually blank it. But having said that, if you've made the effort to actually write the chip, then you may as well protect it from some strange source of UV light sort of leaking in and getting to it. Who knows, over time, it may actually cause one of the bits to flip. And then you've got a slightly malfunctioning ROM. Programmable side is that it needs a programmer. We'll show you that in a second. And yeah, the other thing I should mention is, so I knew what this was when I bought it. So generally you see EPROMs referred to by the numbers, for instance, 2764. I'm assuming that was one of the earlier versions of this chip. As you can see here, this is a 27C64, and also is prefixed with MBM. And above it, you've got an F. So it's a good idea, if you can, to try and match exactly what you see on the chip, because if you do not, you may find that the EPROM programmer has issues writing to it, and you can end up floundering around and changing settings and having a bit of a frustrating time. So to save on time, just try and put in, if you can, exactly what you see there. We'll do that in a second in the software, but I just wanted to show you the F there and the MBM 27C64. We'll be having a look at that in a second. So yeah, a remarkable little thing, the EPROM, and it allows us obviously to create our own ROMs, which is the wonderful thing about them. But obviously to do that, you need to have a programmer. So let's have a look at the programmer next. So this is the EPROM programmer that we're going to be using today. And I originally owned the earlier model of this, which is, I think it's grey and green. I got that about 4 years ago. It turns out that it can't do some of the higher capacity EPROMs. So I actually then invested in one of these, which is a T48 programmer from a company in China called XGecu. You can buy these on eBay. I think on eBay they would be about £60, probably a little bit cheaper if you're in the US. But if you were to buy it from China direct, then you're going to get it for something like £32, £38, something like that. Obviously, the post and packaging might be a little bit higher. Though I find that if you buy things on AliExpress, the packaging price is actually usually quite good. So yeah, it may be worth buying this from China. The only thing you're doing if you're buying it locally is, number one, getting it faster. Number two, obviously paying more money for it. And the reason for that is just because you're getting it faster. So really, the best thing to do is to just order one of these from AliExpress. Just wait a little bit longer for it to turn up and get better value for money. So the reason why I said I'm using this model is because it has adapters. So having bought this, I also bought the adapter that I needed. And you can see here it says for Amiga and Acorn computers. And it says underneath here, it allows you to read in 27C 400s, 27C 800s, and then after that you've got slashes. So I'm assuming it means that these are 27C 160s, 322s, etc., etc. They are larger capacity EPROMs. I think the 800, if I'm right, is a 512K EPROM. The 400, you can imagine, would be 256K. Yeah. So I believe I got this to write an Amiga ROM. So that's what this is for. It just plugs in. There's actually a jack there, plugs in there. And then these pins go in here. Stick the EPROM in and off you go. So how does this actually work? So if you actually have a look at it there, it says IC. It's upside down. Hopefully you can see that there. And it's pointing in that direction. And that means that the notch on the EPROM needs to be at this end. So if I get this blank EPROM, it would be like that. Over here, I've actually got the JiffyDOS EPROM that I burnt earlier. This is actually already written. So the notch is at this end. So if I turn this around and pop it in here like that, that would be ready to read now. All you need to do is pop that little lever down, which obviously pushes the contacts up against it and makes electrical connection. And the other thing we need to do is plug it into the PC. So this USB cable plugs in here. Obviously, this is plugged in to my PC. There we go. I hope you hear that little beep. And this is now ready to go. We can use this now to both read chips and also program them. So what we're going to do next is have a look at a couple of data sheets for a couple of EPROMs before we actually go to writing it. And the reason for that is I just want to give you a little bit of background on how you actually check these chips, get the actual name off them, and then work out exactly what it is that you've got. Yeah, it can help you to troubleshoot. So let's do that next. Before we have a look at those spec sheets, let's have a quick look at the EPROM Blanker. It's an interesting device. It always makes me feel nervous when I use it, but it's very important because once you've written an EPROM, you have to blank it. So you need to get one of these devices to do that. So let's have a quick look at that first. Okay, let's take a quick look at the EPROM Eraser. So I've got this one wrapped up here. You can see that this was a product of China. Not the best product from China, to be honest. Apparently it's Big Moon. I would imagine that this has been copied to death. Copyright very often not being such a big thing in China. You get these on AliExpress. They're very, very ubiquitous, and they all work in pretty much the same way. This has a little flap here, which allows you to get access to the UV light inside here. There's a light bulb, and I put tape over it for some reason. Maybe it's a bit loose. And there's a little drawer here, which is not wonderfully easy to open, to be honest. There we are. You pull that out, and then you pop the chip inside, shut it, turn on the light. There we are. Turn that on like that, with it plugged in, of course. And then the magic light hits the EPROM for several minutes, about 5 minutes, and then it should be blank. If you don't do it long enough, you'll read it in the programmer and you'll see that it's actually not blank. The blank check will fail. So you need to put it in for a little bit longer. Okay, so the reason why I'm showing you this as well is because these things are dangerous. Honestly, they really are. So what I want to bring out to your attention is the thickness of this cable. And I'm going to show you. Can you see that there? That cable going into the plug there? This is a UK plug, a marvel of British engineering. And I don't mean that ironically. It really is a fantastic design. Also fantastic if you've got burglars, put those on the floor. And if you ever stand on one of these things, you'll know about it, believe me. So yeah, it's a kind of caltrop. But if we open it up, now these are actually meant to be earthed, okay, for safety reasons. So we'll just undo that. And just a little bit more. There we go. Okay, and you'll see, number one, I'll just hold that up to the camera a little bit closer there so you can see that. So number one, those wires are incredibly thin. I don't really think they should be used to supply mains voltage. Yeah, that's dangerous basically. And the other thing that's missing is there's no earth as well. You can see there's the earth pin ready for you to use, and they just haven't bothered. So at some point in the future, I would actually like to modify this eraser and actually make it a bit safer, put a more robust cable in there, and ideally, I suppose, you know, try and earth it as well if that's possible. The problem is, I did actually open this up and have a look inside, and what they've done is they've hot glued the point at where the power supply actually connects to the PCB in there. So it's actually, they've made it quite difficult to actually improve on it, actually, to be fair. So what I do is when I run this is I plug it in, I set the timer, and then I basically turn it off manually, and I make sure that I'm in the room when it's on. I put it quite far away from me to make sure that I don't get any leaking UV light coming at me, and I manage it manually. Like I said, it's not the kind of thing that you want to leave the room and leave it for a long time. It's just dodgy, and you should really be in attendance. So yeah, put it a good 10, 15 foot away from you, plug it in, turn it on, let it do its thing, and then go over and manually turn it off, and then unplug it when you're finished, because in my opinion, it's a dangerous thing. I don't know if you can get better, well, you almost certainly can get better devices than this, but they probably cost a fortune. So yeah, it does work, but you've got to be careful with these. So the first EPROM we're going to look at is an AM27C400. This is an EPROM that requires that adapter that I showed you earlier. So this would be suitable for more like an Amiga or something like that. And I'm just going to show you this just to give you an idea of how datasheets work, the most important things that you need to look at to use them. So you can see it says 4 megabits. So 4 megabits is 4096 bits. If you divide that by 8 to get bytes, that gives you 512 kilobytes. So this is a suitable ROM for 512K ROMs in an Amiga, let's say. Now, if it was a 1 megabyte ROM, then you would want to use the AM27C800, double the capacity. It looks like this one has an interesting feature, which is it can actually be programmed in 16-bit word mode. Computers, although we tend to use the term bytes, which is 8 bits, back in the day, many computers didn't necessarily do that. They would sometimes use 16-bit words, and this EPROM facilitates that. So it can actually be written to in a 16-bit mode. And when you do that, you end up with half the capacity in terms of killer words, but it's actually the same amount of data. So yeah, it's still 4 megabits. It's just that you've arranged the data on the EPROM in a slightly different way, in sections of 16 bits rather than 8 bits. It shows you what power it needs to have, 5 volts, etc., etc. How fast it is 100 nanoseconds, which apparently is a fast one. It tells you that it's ultraviolet erasable and so on and so forth. One of the most important things, though, is how you erase it and write it. So to write it, generally you're going to scroll down. Let's just page down. Actually, before we do that, one thing I'd like to point out is it does come generally in 2 different formats. You've got DIP formats, which is what we're interested here, which is the more sort of traditional old-fashioned chip package. And then you've also got PLCC, the square packages, which have pins on the sides and fit into a socket. That's, for instance, typical more when you get into, say, the Amiga 3000, the Amiga 4000 era, Macintoshes from the 1990s. So yeah, you've got to make sure that you order the right type as well as the capacity. Yeah, there's quite a few things you have to get right. And believe me, it's very easy to make a mistake and get EPROMs that you don't need. So yeah, be careful when you're ordering stuff. So we'll just page down until we find the section on writing. Here we are, programming. So it says here that it is in a default of 1 for every bit of data when it's supplied to you, when it's blank. I guess some EPROMs are the other way around. They might be 0. And it says the programming mode is entered when 12.75 volts plus or minus quarter of a volt. So it could be 12.5 to 13 volts. When you apply that voltage to the VPP pin on the package, it will enter write mode and you can actually write data to it. If your profile that you've loaded is not the correct one, that voltage may be incorrect. And you may find that when you try to write the chip, it's not going to work. Okay, so yeah, that's something to bear in mind. Okay, so let's actually have a look at the chip that we're going to write. Actually, this is a related chip to it. This is the MBM 2764. I think it's an earlier version of the chip, but if actually you have a look at the write voltage for this, it's the same as the chip that we're interested in, which is this one here. This is actually the MBM27C64, and it says it is 64K. That's 64 kilobits. So again, we've got to divide that by 8. And if you divide that by 8, it comes out as 8 kilobytes. So in this case, it's basically, I think, counting on the fact that it's going to be in 8-bit bytes. If we'll have a look down here, yeah, actually it says here, look, 8,192 words by 8 bits. So yeah, that's 8 kilobytes. Does it actually have the right voltage down here? It doesn't. Again, on the right-hand side, it does show that it is available in DIP or PLCC packages. This is pretty normal. So we'll just carry on down until we find where it says programming. Here we are, programming. And it says, upon delivery, the MBM, all the bits are in the 1 position again. And it says normal programming down here. The programming mode is entered when 21 volts. So 21 volts needs to be applied to this particular chip, the one that I showed you earlier, the blank EPROM, to make it right. There's a mistake that you can make, and we're going to look at that next in the software. And if you do make that mistake, you will find that you can't write your chips. So it's important to choose the right profile to match exactly with the chip that you're actually using. Otherwise, you may not be able to write to it correctly. So yeah, let's have a look at that next. So we've got our EPROM programmer plugged into our PC using the USB. And we've got, in this case, I've got the JiffyDOS EPROM actually installed in the socket. What we're going to do in a second is we're going to read that in to show you can actually read chips. Right now, it's actually not set up for it correctly. So let's just give you a little quick tour of the software. This button here allows you to actually find chips. You can type in the label here to actually find them. Once you've actually done that a few times, you will have these recently used profiles. So you can go in there and actually get them. That's pretty useful. You've got the obviously very important programming button here when you're ready to actually write out a chip to burn it. You've got verify, and what that will do is it will compare what's in the current buffer here and what's actually on the chip in the burner, and compare them and actually read the data, compare the data in the buffer and make sure that they are the same. And if they are the same, then it's verified. You can blank check. You can't blank the EPROM using this programmer. You can only write to it. Once it's written to it, as I said earlier, you need to use the eraser box of death. So yeah, but basically this is a blank check. So it'll just read in the data from the chip, make sure that it's all blank based on what it says in the spec for the EPROM. You saw earlier, it said that it should be FFF or 1. Some EPROMs it would be 0. So it just basically checks that it's either 0 or FFF, which is the equivalent of 1. And that makes sure that the EPROM is blank and ready to be written to. Okay, we obviously need to load in the right profile. So I'm going to go here to here, and I put in 27C64. So what I'm going to do is I'm going to load in the wrong profile. So the thing is, there are lots of 27C64s, and don't get into the habit of thinking that all 2764s are the same. So for instance, let's say that, let's have a look at this one. Let's select that one. Yeah, this one, for instance, is a 12 volt EPROM. If you were to use this profile with the EPROM that we currently have in the programmer, it will not write to it correctly. It will read it actually. Let's try that now. Let's actually try just reading it. So read, and it says that, and then we'll try and read. And I'm going to make a mistake here. So let's just let that read. Okay, it's saying that it is not in correctly. So let's go back. I think we need to change check ID and pin detect. Let's try that and try reading it again. Read. There we go. And it's actually read in the data. So the reason why you want to do that is sometimes the EPROM has the wrong pin setup, and very often the ID is not matching with the profile. So what you can do is you can just disable the check. You will tend to find that every time the software loads, these are turned on, but you can disable these. These are perfectly safe to do that when you're reading. It's just basically saying don't do these checks. So we can do a blank check. Don't forget right now this EPROM has JiffyDOS written to it, so this should fail. So let's do a blank check, blank, and then it's going to check it, and it's going to fail. That's because it's got data on it. As you saw, we just read the data. So next what we're going to do is we're just going to load in the right profile. So let's do, what was the full name? It was MBM 27C64. And you can see you've only got one option actually, and it's Fujitsu. So that is actually the correct profile that we want to use. So let's just load that up. There we go. And what we're going to do now is let's try and read again. Read. Yeah, that works perfectly fine. And you can see there's the data. So you can read in the contents from a chip and you can then write that out to a file if you wish to. And that is how people actually get data off chips. You find the right profile, you stick it in the programmer, and then you can read the data off it and then store that as a backup as an example. So what we're going to do next is we're going to go to File and we're going to go to Clear the current buffer. I'm just going to blank it. There we go. So now we haven't got any data in here. So if we were to try and write this, program it, it would basically try to write out a blank EPROM, which would be stupid. That's not going to be any good to us. So what we want to do is we want to load in the data. So I'm going to go and load, and I'm going to go and browse. And let me bring that in here. So you can see that I have a number of different EPROMs data sheets here in the JiffyDOS folder. That's just for reference. And if you go down here, you'll see there is a JiffyDOS 1541 bin. There's also a JiffyDOS 1541-2, which is a different size, 16K. But you can see that the one that we actually want to use is this one here. So let's load that. That's 8K. So let's open that. There we are. So let's pay attention to this now. So have a look at the top row here. You can see you've got H space, and then you've got open round bracket. And then on the second line, you've got exclamation mark H. So remember that if you can. The chances are that if we read in that data, it should match what we have on the EPROM, right? So let's just clear the buffer again. So going to clear contents. There we go. And let's just read in the data again. And there we are. You can see H, open round bracket, exclamation mark H. It looks like it's the right data. Can we tell if it's the right data though? So what we want to do is now is we want to clear the buffer again. So we're going to clear the buffer. We're going to load the buffer again off disk. So we're actually going to load up the JiffyDOS ROM. And what we have in the EPROM in the burner should be the same data. So what we're going to do is we're going to do a verify. And it's going to do a comparison between the data in the buffer that we've just loaded and the data which is currently present on the EPROM in the burner. Okay, so let's just click on verify. And you can see it's verified it. It said that the data in the buffer and on the EPROM match. So there we are. That shows that our EPROM has been burned correctly. So what I'm going to do now is I'm going to take out that EPROM and I'm going to try and burn a new EPROM with the same data. Okay, so yeah, let me take the EPROM out. And now I'm going to put in the blank EPROM, making sure I get it in the right socket and make sure then I lock it down. What I'm going to do is, first of all, I'm going to do a blank check on it and just make sure that it is actually blank. So let's do that. It says the device is blank. So it looks like we're ready to go. We've got the right profile, 21 volts. It should write, hopefully. So let's go for it. Let's try clicking the program button and then writing it. Now, what I'm going to end up with is another EPROM with JiffyDOS on it. So I'm going to have to crank out the box of death when this works and then pop it in there, and that should then blank it and get it back to being ready to be used for something else. But anyway, before we do that, let's try actually program it. So click the program button and cross our fingers and program. Looks like it's doing it. Well, hey. Programming succeeded. Okay, let's go back. Let's clear the buffer and now let's read it. Yeah, looks right. H, angle brackets, etc. Okay, so what we're going to do now is we're going to clear the buffer. We're going to load the data from disk and we're going to do a verify. So always a good idea once you've actually written out an EPROM to do a verification, make sure the data is written out correctly. And you can see the verify result is fine. It's actually worked. So there we are. That's great. Interesting question, actually. I wonder what would happen if you actually wrote out a buffer that was basically empty. I'm guessing there's a technical reason why that wouldn't work, why you've actually got to physically empty a chip. Yeah. I guess it's because it can't go back to the empty state, right? It only can flip the bits to the other state. It can't revert them. Yeah, I think that's what it is. So yeah, the only way I can actually get this EPROM now to be usable again is to put it into the blanker. So I'm not going to do that in this video. Actually, tell you what, let me just do it now. I'm going to stick it in there and come back in a second and then we'll blank check it, okay? So yeah, let me just unplug it and take it out. And I'm going to take and pop it in the box, and then we'll give it a blank. Yeah, the draw on this is quite tricky to get open. There we go. Okay, that's done. Let's get it out of here. Let's check if it's blank. Okay, so it's been in the blanker for, I think it was about 7 minutes. I think 5 minutes would do it, but I just wanted to make sure. Let's pop it back in the programmer. Make sure it's latched in there. And let's do a blank check. Blank check. The device is blank. There you go. So 7 minutes in the box of death has sorted it out. We've got it back to a blank state again. Okay, great. So I think that's it in terms of showing you how to use this. Let's move on. So this next section originally was going to continue on directly from the intro. But as we saw earlier, I decided that it made more sense to actually show you how to make an EPROM because we're going to use it in this section. So please bear that in mind with what I say next. Yeah, this was a continuation of the intro. So yeah, hopefully that makes sense. With that being said, let's get on with the show. Okay, so let me just show you up close some of the things I was just showing you there. This is the socket sort of contraption that I was showing you. And you can see now you have a smaller socket, which is actually the size of the kernel ROM socket in the 1541 drive. And then on top of it, you've got inserted a larger socket, and this is actually the right size to fit the EPROM into it. Obviously, you can't put the EPROM into a small socket, so you have to make an adapter like this. But like I said, to make this work, you'd have to have wires going in this area here from certain pins to certain pins. And what we're going to do today is a little bit cleaner than that. I'm actually going to use this to hold the pins in position when I do the soldering. So let me just take this apart. There we are. So I'm going to use this one because I need to put the pins into this, which will hold them straight so that when I solder it, they're actually upright correctly. Otherwise, we might end up with wonky pins. And the problem with these round pinhole sockets, although they are better in that they keep better contact, is that they're really quite hard sometimes to get things to fit into them. So you've got to make sure that the alignment is perfect. Otherwise, it might be a bit of a nightmare to do that. So this is the simpler of the two boards. This is for an 8K ROM. Yeah, it's pretty basic. You can see you've got the small run of pins there. That's for the pins that go into the actual socket. And then you've got the larger on top. And that's where we're going to put this larger socket here. That's just going to fit into here. There we are, like that. And yeah, that's going to be our adapter. So that's pretty simple. This is the slightly more complex version. This is the 2364 to 27128. And as you can see on this one, you've got a space here for a resistor. I have the resistors and a header. I have those. So I'm going to make one of these, but like I said, I just don't know if we're going to have that 27128 EPROM, so I can show that on this video. Fingers crossed we do. And if it turns up in time, then yeah, that'll be part of this video. So we'll see how it goes. As I said, this is useful because you can swap then between the low and high parts of that EPROM. And you can have two kernel ROMs on the same EPROM, which is quite cool. What else I've got to show you? Well, actually, I've already made one of these. I ordered some of these pins. I made a mistake and I ended up getting basically square pin header pins. So I went ahead and made this socket. I could desolder this top socket, but for now I'll just leave this as a sort of learning project basically. But this does actually work, but it's going to make the socket that it fits into probably have too large a space for the pins because these are actually quite chunky. So we're not going to be using those today. We're going to be using the correctly sized round pinholes. I struggled to find the name. I believe it's round pin headers. And you have to make sure that you got the pitch right and all that kind of stuff. So what I'll do is in the description of this video, I'll put some text down there explaining exactly what these are called. The best way to buy them is to buy them from AliExpress. You can get them a lot cheaper, obviously, than buying them in your local market. I did buy some from the UK as well to get them quickly. But then I also ordered a bulk order of them from China. And that took like, I think it was about a week for them to turn up. But, you know, probably a tenth of the price to get them from there. What I've already done is I've cut 2 of these to length. So I've actually got the 2 pins to go in. So let's put those into the socket. I did test this earlier and it did actually go in quite easily. There we go. Just make sure that I put them both in the right way. I'm going to leave the longer pins pointing down with the smaller pins ready to go into the actual adapter. Now, the other thing we've got to be careful of is that we don't solder these the wrong way around. So which one of these will we do first? So let's have a look. That has to go in there. And that is going to make it very difficult to solder these. So it's actually this that has to be done first. So I'm glad I checked that, because that would have been painful if I did it the wrong way around. So make sure we get this aligned correctly. There we are. That's slotted in, that's slotted in. Just put that there where you can see it. And let's get my soldering iron and my magnifying goggles, and let's get this soldered. So I'm just going to leave the iron to warm up. I'm going to put a tiny bit of flux on here, not much. Doesn't really need that much. Okay, so just hold that. Just putting a tiny blob on each one. There we are. Put the cap back on this just so it doesn't leak. And let's go for it. So the first thing I'm going to do is I'm going to pin 1 pin on each corner, just to make sure it holds in position. Just letting the heat sink into the pin before I apply the solder, just to make sure that it runs down. Well, that one's a bit much. Now these ones. There we go. Once that's done, let's get all the others done. There we are, that row's done. Now for the next row. There we are. Quick inspection, just make sure that's okay. Yeah, it looks okay. Looks pretty good. Okay, next I'm just going to put a little bit of flux again on the other row. And let's get the socket in as well. Actually, it needs to be the other way around, isn't it? Nearly made a mistake there. Let's pull this out. It's quite hot. Oof. Being gentle, not to bend the pins, obviously. Yeah, now this time obviously we need to solder from the underside. So let me just put the flux on this way. Just a tiny dribble on each one. I'm going to have to be careful that I don't melt these plastic parts as I get close to them. There we are. A little bit of tiny bit of flux to help things fly along. Next, we'll put the socket in from the underside. There it is. Lay it down nice and flat, just turn it around. And as I said, I've just got to be careful this time not to melt anything. So let's just check everything's right. Yeah, it looks good. Let's do the either end first, like I did last time. There we are. That's the corners. Now for the other pins. I think let's have a look. That looks pretty good. Everything looks good there. And everything looks fine there as well. So there we are. We've got one adapter ready to go. Okay, so next we need to set up this area and we're going to try this out. So yeah, I'm not going to bore you with me inserting this into this because it can be quite fiddly. So I'll probably do that off camera, get it plugged in there, and then we should be ready to go to actually insert this into the 1541. Okay, so I've got my Commodore 64 set up here. We're going to load JiffyDOS onto the kernel of this machine using the Easy Flash. So we'll turn on the machine, we'll turn on the drive. There we are. If we have a look here, Easy Flash allows you to replace the kernel ROM in the machine. You just have to choose one there in the top left. And you can see number 6 there's JiffyDOS. So I'm just going to load up JiffyDOS. And the first thing we're going to do is we're going to check the kernel ROM on this machine, make sure it's the original one. I mean, it is. It's actually there, but if you press @ it'll give you the error status of the drive and it'll report basically what the ROM is. That's the first thing it'll do. And you can see there it's saying that it's Commodore DOS version 2.6. So that's the standard version. What we're going to do is we're going to use Stationfall, one of the classic Infocom games, to benchmark this. I know that JiffyDOS can be incredibly fast. It does vary. It doesn't accelerate everything in a uniform manner, but it generally is a lot better than not having it. Let's put it that way. There's the disk. It's one of the few commercial bits of software I have actually for the C64. I do own pretty much the entire Infocom range, but it's a smattering of Atari 800, CBM, TRS-80, various different machines, because they basically publish their games for almost every platform out there. So let's pop it in. And what we're going to do is, I've got a stopwatch here, and we're going to set this off as soon as I press load. And we're just going to time how long it takes to load the game. Then we're going to take out the kernel ROM, and we're going to pop in this new one here. And we'll see what difference it makes having the JiffyDOS ROM in there. Okay, so shift run stop will load it on here. So start. And it's going to say, yeah, asks you actually if you're loading on a 1541. I don't know why it does that. There must be some technical reason, but it does ask you. So I pressed that as quickly as I could to get the benchmark to be as accurate as possible. So now we just have to wait. I've timed this before. It should take a little bit over a minute. So let's just see how long that takes. And we'll obviously fast forward time because we don't want to sit here and just wait for it to load. So yeah, let's do that now. There we go. Stopped. So yeah, 1 minute, 9 seconds, almost 10 seconds. Maybe I'm not so fast anymore. I'm getting old, so maybe it was 1 minute 9 bang on. So there we are. That's kind of typical of a 1541 disk drive. It does take quite a long time to load anything. So let's just reset that and let's get ready to put in JiffyDOS. So I do actually have my chip puller. So let's just use that to get the original kernel ROM out, making sure we turn the machine off first. There we are. And this just makes it a little bit easier, although to be honest, it's always a little bit of a wriggle. There we are, got it out. There we go. And made sure I got the notch in the right place on here, notch there. They're both aligned. Okay, that's plugged in. Let's turn off the machine. We'll turn it back on again. Turn on the disk drive. Seems to be okay. Let's go back to JiffyDOS. And we'll use the @ symbol to get the status of the drive. There we go, JiffyDOS 5.0, fantastic. Okay, well, let's not beat around the bush. Let's benchmark this. So ready, shift, run stop, and start. And there it goes, yes. We'll see if any improvement is gained from having the JiffyDOS in there. Here we are. 45 seconds. Not too bad. What's that? Okay, 25 seconds, something like that. Pretty much 25 seconds. Well, that's a pretty big improvement, isn't it? I know that with some software, it's even better than that. It's like, it literally takes like a minute to load something with the stock kernel, but with JiffyDOS installed, it can actually take 10 seconds. Yeah, it's literally that fast, the difference. When I'm playing Wasteland what I don't want to be doing is wasting my time waiting for the game to load, you know? So yeah, it's just one of those things you really have to do with the 1541 is get some kind of acceleration in there. And yeah, my particular choice is JiffyDOS. So that went pretty well, didn't it? I'm very happy with the outcome of that. The 1541 now has got JiffyDOS installed, and we're ready to actually play Wasteland. I know there's a bit of a setup procedure for actually playing this game, so we're not going to play it here. Obviously, this video has gone on for quite long enough. Let's get the disc out for Station 4, pop it back in its sleeve, keep it safe. And I'm just going to put in the boot disk for Wasteland, and let's load it up. There we are. So let's go to JiffyDOS, and there we go. JiffyDOS is working. And yeah, let's load up the game. So Shift Run Stop. Take this off here just in case it causes any extra heat to build up. And as you can see, it's loading fine. So yeah, anyway, I'll leave that loading. So what can we do from here? Well, unfortunately, the larger EPROM, the 16K EPROM that I needed to use the ROM switching adapter, unfortunately, that hasn't actually arrived. So we're going to have to delay that for, I think now, well, it's going to have to be another video, isn't it? I think what I'll do is with that video is I'll release that to channel only members, not permanently. I think we'll do it for a period, maybe 2 weeks or a month, something like that. So we'll give them some exclusive access to that for a short period, and then I'm going to release it to the public. I think it's an interesting solution, so I don't really want to keep that in quotes secret behind a kind of paywall. But if you do want to see that video sooner rather than later, then please join the channel. It doesn't cost much. It's just a small amount of money that you can use to subscribe every month. And it will help this channel to grow and to improve on the content that we produce. It's expensive to make these things. As you saw, I had to buy these adapters from PCBWay. And talking about those, I will be putting those on eBay. I'm not sure if they're going to be available immediately as soon as this video is released, but very soon after, I hope to get those up there. I'm going to try and do one of those eBay pages where you can have multiple options. So I'm thinking possibly I might sell the little boards on their own, possibly as a kit, and then maybe even fully soldered up by myself. Yeah, I'll get an eBay page set up and hopefully you'll be able to buy those off there if you're interested pretty soon. I think it's really cool what PCBWay do. Their project pages, what they basically do is they allow people to upload projects, and then if you order the project from PCBWay, a certain percentage of the money from that actually goes to the original creator of the item. So as we saw earlier, there was actually an author of these projects, and some of that money that I paid will actually go to them, as I said, for their input into the PCBWay projects. I've had a look on there for other projects, and there's some quite interesting stuff which I hopefully will be bringing to you in the future. And as I said, one of those projects was actually the other EPROM adapter, the one that allows you to have 2 images on a single ROM, which would be the sort of ideal thing really to have inside this PC, so I can swap back and forth between having just the stock kernel ROM that came with the Commodore 64 or obviously JiffyDOS. There are a few titles which I understand are incompatible with JiffyDOS. There aren't that many, but they do exist. So it could be quite useful to be able to switch back to the standard kernel ROM if you needed to. Anyway, this video has gone on long enough. I think you'll agree. I hope you enjoyed it. And if you're new to the channel, then please make sure you like the video. Clicking on like really helps the video to get out to other people who are interested in it. If you type in adapter and some other person's video which has more likes appears, it will actually turn up top of the search results. And it may not be a better video than this one. It just may have received more likes over time. So if you really want to help this video to go to people, please click on like. And if you want to see more videos from me in the future, then please click on subscribe. Clicking on subscribe will obviously get you a notification of when new videos are coming out. To do that, you have to click on the bell. But obviously subscribing to the channel helps the channel grow, because YouTube will then obviously help by promoting my videos to more people. The more subscribers I have, the more people my videos will go out to. It's a bit of a struggle to get subscribers. So please, if you did enjoy this video, please subscribe to it if you're not already a member. And if you really want to help the channel grow, as I said earlier, you can become a channel member, and that really helps me in a material way to actually make these videos. Anyway, enough of the commercial waffle. As I said, hope you enjoy the video. Until the next one, take care and have a good day.